we are going to move to example number 3. Okay, so example number 3. Read through the question. Okay, the transfer function of LTI system is given by Hz is equal to... Alright, so if you look at this transfer function is actually not similar to our general transfer function, right? So basically our general transfer function must be in inverse Z function. Okay, so what you have to do first is actually we have to create the Z inverse transfer function. So how to create the Z inverse transfer function? You have to divide your function with Z squared. Why Z squared? Because of you look at your denominator part. If you combine the Z, it is Z squared. So the highest order of denominator part is Z squared. Alright, so Z squared, you still have to divide with its own function, Z squared over Z squared. Why? Because of we don't want to disturb the original transfer function. Okay, so basically here you have okay, so next we are going to move to next question. Okay, the question is determine all poles and zeros values of Hz. Okay, so again poles value you get from the denominator part. So from denominator part you know that your Z equal to 0.1 and 0.2. Okay, zeros value you get from your zeros value you get from your numerator part. So your numerator part is equal to minus 3 and 0.5. Okay, so next for part B, classify whether Hz is minimum, maximum or mid-phase function. Give your reason for your choice. Okay, so for you to know that function is classified as minimum, maximum or mid-phase, you need to refer to the zeros value. So in this case, your zeros value is outside, and then you have another one which is inside unit circle. So basically it is the combination of inside and outside unit circle. So for question B, the answer is it is mid-phase function. Because Z equal to minus 3 is outside unit circle and Z equal to 0.5 is inside unit circle. So the combination of values inside and outside unit circle represent mid-phase function. Done for part B. So now we move to part C. Determine minimum phase function in cascade with all pass function. Same thing. Okay, so you have same thing to similar to example number 2. So you have the Hz. Okay, so next we have to look for the function which is outside unit circle. So the function outside unit circle is 1 plus 3z minus 1. So the mirror of 1 plus 3z minus 1 is 3 plus z minus 1. So again, we have the new added function. We don't want to disturb the original function, so we divide with the same new transfer function. Okay, so what's next? H all pass, you remember the equation. It is z function outside unit circle over mirror of z function outside unit circle. So we have this over this. So basically we know that H all plus z equal to 1 plus 3z minus 1 over 3 plus z minus 1. So the remaining function is okay, done for CA. Okay, now we move to CB. Okay, for CB you have to determine H minimum phase and H linear phase. Okay, so same thing, we have Hz equal to times with the mirror of z outside unit circle. So what you have to do next is, okay, so for H linear outside unit circle times mirror. Okay, so H linear z is, so the remaining function will be your H minimum z.